Okay, ladies and gents, well, here we are, our first attempt at a flipped classroom. On this first slide, I have your objectives listed for you. Please read them carefully. These are the goals, the things I want you to be able to accomplish at the end of the video. Can you create an isosceles triangle? Can you prove that bisectors of vertex angles of isosceles triangles bisect the base and that it is perpendicular to the vertex of the angle? If given any of the angles in an isosceles triangle, can you figure out the other two angles of the triangle? I'm going to take you here to see the links. I'll put these links at the bottom of the video, but you'll notice that this definition of a segment bisector takes you to a website that allows you to manipulate the line, so I'm going to attempt that right now. So here's the website, and you see that it gives you the definition of a line segment bisector, but you also can click here and drag the orange dot, and that will allow you to simply see how bisectors can operate. They always divide the line into two equal parts, but they can run perpendicular or not perpendicular. And pull this up. There's the website at the top now of the screen, so you can see that. This webpage is MathBit's notebook, and it's a reminder about the corresponding parts of congruent triangles are equal. And it would be a website that would be worth you taking time to go to, just simply as it goes through and gives you great proofs. Goes through, and you'll see I'm just kind of scrolling for you to get a view of the side, 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 angle, and angle, angle, side. And here we end up with corresponding parts of congruent triangles are congruent. So again, that's mathbitsnotebook.com. Okay, back to our PowerPoint. Okay, the next thing that I'd like you to do is to actually pause this video that I'm creating, and down at the bottom of the video page, the YouTube video page, you'll see a link, and it's going to take you to this isosceles triangle video created by CK12 Productions. So go watch that and then come back to this video. Welcome back. So reflecting on that video, do you know what makes an isosceles triangle isosceles? And do you know which side of an isosceles triangle is the base? Well, the answers to each of those, you can know that an isosceles triangle is isosceles if it has at least two sides that are the same. And of course, mentioned in that video was the equilateral triangle as well, but we typically call an equilateral triangle equilateral rather than isosceles. You know that the base of an isosceles triangle is the base because it is the opposite of the vertex, and the vertex will be in between the two sides that are the same. Okay, pause one more time this short video, and this time you're going to go watch a video on an example of determining the angles of isosceles triangles, and this short video that you're going to watch on YouTube actually has two different examples for you, and then we'll see you back here at this video. Alright, so we ended off with a review of our objectives. Can you create an isosceles triangle now that you know its attributes and its definition? Can you prove that a bisector of the vertex angle of an isosceles triangle bisects the base and is perpendicular to it? If given the angle of the vertex of an isosceles triangle, can you figure out the angles of the bases? And vice versa, if you're given an angle of a base, can you figure out the angle of the other base and the vertex? I hope so. Write down any questions that you may have, and I'll see you tomorrow in class. I'm looking forward to discussing this together.